Hi, my name is Nakamura. I'm a grad student at UT Austin. And today I'm going to tell you about a project I'm working on about constructing trace embeddings from zero surgery homomorphisms. So the big open problem in our field, of course, is the smooth four-dimensional point K conjecture, which asserts that every smooth four-manifold X homotopy equivalent to S4, i.e. a homotopy sphere, four sphere, is in fact diffeomorphic to the standard four sphere. And a counterexample of this conjecture is called an exotic S4, i.e. a homotopy four sphere that is not diffeomorphic to the standard four sphere. So Mandolescu and Piccirillo recently proposed a way to build an exotic S4 and disprove smooth four-dimensional point K conjecture. Their approach starts with two knots, K and K prime, which satisfy three conditions. First, K is slice. Second, K prime is not slice. And here we need to obstruct sliceless from K prime having non-vanishing S invariant. And three, there's a zero surgery homomorphism between the two knots. So the first condition allows us to build a slice disk exterior E of D. The third condition, the zero surgery homomorphism, allows us to glue the zero trace of K prime to E of D to build a four-manifold X. And this X will be a homotopy four sphere. Now, once you have condition two, we can see that X is actually an exotic S4. Basically, by construction, K prime is slice in the associated homotopy ball. However, K prime is not slice in the standard four ball, because it has non-vanishing S invariant. And so sliceness of K prime smoothly distinguishes B and B4. So the associated homotopy sphere cannot be standard. Okay. So Mandolescu and Piccirillo conducted a search for such a pair of knots which satisfy these three conditions. So they found pairs of knots that satisfied condition 2 and condition 3, but they couldn't immediately determine condition 1 for these pairs. And so condition 1 held, we would have an exotic S4. And so they found 5 such pairs and conclude that if any of these K1 to K5 are sliced, then an exotic S4 exists. And recently, actually, I ruled out this possibility and showed that these knots, K1 to K5, are in fact not slice. To do this, the main step was proving the following key lemma, was that if any of these Ki was slice, the associated knot Ki prime would bound a null homologous disk in connected sum of R copies CP2 minus open four ball. And by the way, we say that such a knot is H slice in RCP2. So the idea behind this lemma is really examine the zero surgery homomorphism and use a slice disk for Ki to build a null homologous trace embedding, which gives us an H slicing of Ki prime. Now, why this lemma helps is that these Ki are actually very tough to work with in regards to the concordance. They're topologically sliced. Pretty much all smooth concordance invariants vanish on them, at least the ones that are easily computable. And so instead of working with these Ki, we work with these Ki prime instead. In fact, once you have this lemma, it's not too hard to show that these knots aren't sliced. So if Ki was sliced, the lemma says that Ki prime is H slice in RCP2. But it's known that such knots have non-negative S invariant. But all these Ki prime have negative S invariant. And so we get a contradiction and conclude Ki could not have been sliced in the first place. All right, thank you for watching my talk. I know I skipped a lot of details. I went very quickly, so please let me know if you have any questions. Thank you.